All right, in this one they want us to find all the points of intersection between cosine of 2 theta and that's that clover leaf we looked at in a previous example, and the circle r equals a half. Well, we looked at in a previous example, if you want to find those, set them equal. So let's set these two equations equal to each other and solve. So if we wanted to solve this one, what we would do is figure out, okay, we got cosine 2 theta equals a half. If we do inverse, that'd be where does cosine inverse of a half, what angles does that give us? If you go in your calculator and do this here, cosine inverse of 0.5 gives us that in radians. I'm going to divide the pi out here. That tells us this is pi over 3. So that tells us 2 theta be pi over 3. There's some more angles though. This is our x value if we're talking about cosine. That is positive. So on the unit circle, places where we have positive x values would be quadrant 1 and quadrant 4 down here. So the equivalent one there would be, we got pi over 3 would also be pi over 6, or sorry, negative pi over 3, which would be the same as 5 pi over 3. But that's what 2 theta equals. So what we'd have to do now to find what just theta equals would be to divide these by 2. So you would get pi over 6 to be an answer. 5 pi over 6 would be an answer. But these are only 2 of them. We got our value of like pi over 6. That would be this one right here. And if 5 pi over 6, if we kept going, would be over here somewhere. How do we get the other ones? Oh, there's some more here too. Well, that's because we could keep going. This is not even halfway around the circle yet. So what if we added on to these upper 2 up here? What if we went around the circle again and got those? So if we add 2 pi over 3, pi over 3 plus 2 pi, let's get a common denominator there. That would be adding 6 pi over 3. So we would get that another one would be 7 pi over 3. And if we did the same thing and added 2 pi onto 5 pi over 3, we'd get 11 pi over 3. So if we continue and also divide those by 2, because we want to find just theta, not 2 theta, we have some more answers here. So 7 pi over 6 would be an answer, and 11 pi over 6. So those would give us these other values on here as well. So this one would be, here's where 7 pi over 6 would be, and 11 pi over 6 would be here. But that's still not all the intersection points. We still have some other ones here. How do we get those other ones? Well, you could find those by symmetry and figuring out where those symmetrical points would be. We could also, another way to graph the circle 1/2 would be to graph the circle -1/2, and you could do that too to find these other ones. So if you put equal to -1/2 and did that, if we did inverse here of -1/2, that's going to give you some other possible ones. That would give us the ones on the other side of the circle. So here, if you did cosine inverse of -1/2, that's going to give you like the angles 2 pi over 3 and 4 pi over 3. If we keep going around the circle again, like we did with the last one, we'd also get 8 pi over 3 and 10 pi over 3. Now dividing by 2, just theta, then we'd get the other answer. So this would be 2 pi over 6, 4 pi over 6. This one can be simplified, or sorry, both of those could be simplified. We'll simplify them in a second. 8 pi over 6 and 10 pi, 3 here. So if you simplify all those ones out with just simplifying the fraction, you get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So those are those other intersection points on the circle. Showing you over here, this would be the pi over 3, um, and so on, and we get these other points here. So those would be ways, or use symmetry. Just so you can see another picture of this another way, another graphing tool that's available is something called Desmos. If you go on to Schoology here, there's a link for the Desmos. We'll look at that. So here it gives us a picture. This is a picture of that when we are looking at, or something similar to that four-leaf clover we were looking at. We could change these here to kind of give a similar one here. So I'm going to graph these. So if we change them to match ours, this is cosine, and this is 1/2. So this one shows you a similar one here. You can see that circle. So this is another way to do these ones. I just one thing I wanted to show you on this is if we find the area of these ones, how that area moves. So you can see as we change these, you can see how that area fills in as this angle moves. You can see how the green area fills in here and how this loops around. So when finding area, it carves out as that angle moves, as that X on there on that green line moves. You can see the area, how it fills in. That's kind of how, if we were doing the area problem, that you would think about finding the area of those. So that just gives you another perspective of these types of problems.